Alright guys, welcome back to the CompTIA Linux Plus review. Today we're going to be talking about Chapter 6. This section is all about files and directories. Specifically, we're going to be talking about how do we edit files and directories. So by the end of this chapter, you're going to understand what nano and VI are. Now it's going to take a little bit of practice to get used to some of these, but they are wonderful tools for editing text files. We're going to know how to search the entire file system by using the commands find and locate. We're going to look through and be able to perform operations like creating links, archiving data, and compressing files. Under text processing tools, we'll learn how to filter and manipulate data. And then lastly, we'll learn about redirects and how we manipulate the output of one command to another. All right, so we were talking about our digital filing cabinet. In the last chapter, we were talking about building the library. This chapter is what's inside the books themselves. We'll zoom in to see what we can manage with our storage and see what the actual data inside our files. As we go through this, we're going to remember that our core philosophy is everything is a file. Remember that this is probably one of the best and most powerful concept that there is in Linux, that a document is a file, a directory is a file, the hard drive is even a file, the keyboard is a file. Remember, everything within Linux is presented as a file, and we will interact with it as such. So how do we create and edit text files in Linux? Now, most of the configuration is done in plain text. Now, we do interface with our systems using command line text editors, and we're basically running on our shell. Remember, the Born Again shell is what we are utilizing for this course. And understand that for any administrator, we must be very comfortable with editing files. Now, this could be using with Nano and VI tools, which are text editors that are not going to use the graphical interface. We're going to do everything from the command line interface as an administrator should be. So these are the two editors that we're going to talk about and are highly tested upon on the CompTIA Linux Plus exam. You're going to see Nano as it being a very beginner-friendly and straightforward tool. If you've ever used Notepad or anything else, it's pretty much the same. The nice thing about Nano is it gives you a lot of cheat sheets at the bottom of the page, and it's one of those easier tools to use. On the other hand, we have VI or Vim, the old try and true. VI and Vim has been there since the beginning, but it has a much steeper learning curve. For those who have not been in this tool before will understand what I mean by it is not beginner friendly. Now, it is extremely powerful for those who know how to use it, but it is one of those things that, well, we're going to need to build some muscle memory when it comes to VI. So if you haven't done anything with Nano or VI in the past, please make sure that you launch into the labs and play with these tools. So when we first use Nano, we are going to use the command nano, and our argument is going to be the file name.txt. Just start typing. It's a normal text editor. Now there's a couple different symbols at the bottom. One of the symbols is the caret key. You'll see that at the bottom left, at the bottom of the screen, where it'll show like caret K, caret W, caret Q, all these things. And you're like, well, what does caret mean? Well, this is the equivalency of the control key. So in order to use one of those keys, you need to hit the control key. So in order to exit, control X will exit it. The nice thing about Nano is Nano will ask you, do you want to save your changes before exiting? And if you do, you'll hit yes or no and hit enter. Nano, again, is very beginner friendly, but be aware that if you do not have write privileges to the file, you may see an error message that says access denied as you're doing this. But there is a buffer in that you can save or not save as you go through. Now, on the other hand, we've got VI. VI is a advanced feature, and it confuses a lot of beginners because it's not as clear cut as Nano. There's a couple different modes that you need to understand when utilizing VI. When you first enter VI, you'll type VI in a file name and hit enter, just like you would with Nano. But when you enter it, it just doesn't work by default. By default, you're in what is called command mode. Command mode means we can type different keys on our keyboard to enter different modes. These modes could be insert mode or append mode or cut and paste or search mode. There's all these different modes as we go through the editor itself. Now remember, we are also in command line, so everything is going to be using the cursor and using the arrow keys on our keyboard. We will not have a mouse to be able to use. Now, on the other hand, when we are ready to type, we can go into what's called insert mode. Insert mode can be found by typing the letter I on your keyboard, and you'll notice at the bottom left corner of the I, it will tell you that you are in insert mode. Once you start seeing this, now you can input text into your file. When you are done, you'll hit the escape key to go back to command mode, which then will allow you to do different commands. For instance, maybe I want to write the file and then quit. I would hit Shift:, W for write, Q for quit, and hit enter. Again, this is one of those things that's going to take some muscle memory to get used to. Here's our basic survival guide for VI. VI file name, hit enter. Now we're in VI with a name called filename.txt. I'll hit I for insert mode, start typing my text, hit escape for command mode, and then hit : write quit, and hit enter. It will exit out of VI and save my text file to the computer itself. Now again, there are a ton of commands in VI that allows us to do a lot of advanced features such as find and replace, cut and paste, also search features. There are 1.5 billion features for VI. And I do highly recommend actually taking a look at the manual page of VI so you can start becoming familiar with some of the commands that you can do. I don't expect you to memorize it, and neither does the test for CompTIA. They don't want you to have these things memorized, but they do want you to know the very basics of how do I enter VI, create text, and exit out of VI with saving. Now, once we move past nano in VI, we can start looking at other commands within the file systems. CD and ls is great. We can start navigating around the system, but what if we want to do a search on our file system directories? Well, there's a couple different commands that we can utilize. The first one is going to be find. Find is one of the more powerful and precise searches out there, and it will search the live system based off of whatever criteria you give. It's kind of slow because it's a live search and it has to go through each directory to find data, but it is very powerful. Find has a lot of extra capabilities, including find files older than X amount of days, and then maybe delete these files automatically. Now, on the other hand, we have another tool called locate. Locate is kind of like an index search tool. Locate is newer and is not in all Linux operating systems, but if it is included, it is quite nice because it is an indexing tool. It's incredibly fast because it's not searched in the live directory, rather it's searching for files within its database itself. Now, what's great about this is if you're looking for a specific file and it's been indexed, it is super fast. But on the other hand, if the file has not been indexed, then it's really hard to find because it won't be in its local database. It will say that the file doesn't exist, even if it does. So be careful when you're using find and locate. Know that there are some strengths to locate, but it's not the be-all tool. That you also will have to learn how to use find as you go through. So if I wanted to use find, here's an example of using the find command. Find inside the etc directory a file that has a name of anything star.conf. So this is a wildcard where I'm looking for anything that's named that ends in .conf. In other words, I'm looking for config files. I could find maybe all directories within a directory itself, find in the home directory the type of directory for the user student. So basically, I'm looking for any of the directories inside of the home directory that is owned by the user student, and it will return any of those directories. Maybe I want to find files that are larger than X amount of size. So starting in the root directory, let's find anything that is size greater than 100 megabytes. Now, when I say in the root directory here, just be aware that it's not going to look recursively, in other words, look in folders further down from the root directory, unless we give it the -r command for recursive finds. By default, it will only find in your current directory or in the directory that you specify. Now, here's the strengths of a find. Find is one of those really great scripts that you can run inside of one of the great commands you can run inside your scripts by using the exec command. So here I'm finding anything in my current working directory with the name of .tmp. So if I find anything with .tmp, I'm going to run the remove command on it. You'll notice the syntax for the remove command is open and close French brace / semicolon. Now this is standard, and basically what I'm saying is anything you find, we're going to pass it as an object to the exec command one at a time, and it's going to fill in the blanks. Now this is one of those commands that I'd be very, very careful of running due to the fact that, again, we're running an rm command on our system, and depending on where I'm at, I could delete files inadvertently. So remove is one of those commands that I'm very touchy about utilizing, and I try to not use relative pathing when I deal with this. I deal with absolute paths. The reason for this is if I use absolute paths, then I can't mess up and delete a file out of a directory on accident. If I use relative paths, like using this period, saying in my current working directory, if someone moves that script or the script moves directories, then I can delete files on accident in the wrong directory. So be very careful in how you use this command. The locate command is pretty easy. You can say which file, like let's say locate SSH, which directory with SSH in the name. Now, what's really great about locate is it's not an absolute search. So just by typing SSH, it's already saying, hey, there's a wildcard here. Is there something with SSH in the name? Now, sometimes it might be out of date, and so we can update it manually by doing sudo update db. And I do recommend using sudo on here because if we don't use sudo, what's going to happen is we won't be able to get all the files. Some of these files need to have special privileges to be able to see. So if we run this as root, root can see every file on the file system and update the database accordingly. Now, if we go beyond basic management, we may need to inspect different tools or different files within our system. And so by looking at some of that extra metadata, we may be able to get some extra information. So for instance, we have two files that we can talk about, which is stat and file. One will give us the metadata of a file to include creation, modified, and last access dates. We can create links, otherwise known as shortcuts, by using the ln command, or we can archive or compress files by using tar or gzip. So in Windows, we're always used to using the zip command, but in Linux, we normally don't have zip, but we do have tarballs, and gzips as we go through and encrypt or compress our files. So inspecting that metadata. So the two first commands we wanted to talk about is file and stat. File can do an educated guess of what kind of file is this. So if we see file and we give it a file name, it'll look at the file name and tell us what type of information it is. It's using hexadecimal to help identify some of the information to try to identify what the file is. But it's not always perfect, so be careful when you use this. It may say it's an image file when it may not even be an image file. It's all depending on what the hexadecimal data is giving it. On the other hand, stat is one of those commands that you're probably going to use all the time. Stat of a file name provides a lot more detailed information about a file, including its size, permissions, ownerships, and all those timestamps I was talking about, to help give more information about a file. Now, if there is some corruption in the file itself, it will actually show you some of this information as well. For instance, if the file is not accessible by the file system itself. Now, we want to create a couple types of links. There's called a soft link, or called a symbolic link, or a hard link. Now, there are two different types of links when we're dealing with shortcuts within the Linux operating system. In Windows, most of the links that we know are called soft links. They're called shortcuts. And a shortcut is if the original file is deleted, the link breaks. It doesn't delete the original file, it just breaks the link. Think of this as a secondary file that with a sign that says, hey, you can find the file over at this location. On the other hand, we have what's called a hard link. A hard link has the same name for the same data. If the original is deleted, the data remains, and it cannot cross file systems. So what we normally see here, what we normally see here on hard links, instead of it pointing to a sign saying you'll find the data here, the actual code, the file, is pointing directly to the hard drive location of where that file is found. Think of it having two addresses for the same file. I can have one on my desktop and I can have one in a different directory by having a hard link. But be aware, if you are going to mess with a hard link, you have to be very careful when you're dealing with the data. Because if you delete one link, the other link may still be there, but the data itself is not marked for deletion yet. So remember, you have to have at least one address for every file on the computer. And so think of it like a house number. If I got rid of all my house numbers on the house, then the house doesn't exist anymore in the system. The data is no longer there. But as long as I still have one house number, I can keep this data around forever. So the next thing I want to talk about is archiving and compressing. So a lot of times we're going to want to archive or compress our data into smaller files. Sometimes it's to get a multiple files into a smaller package, so it's easier to copy around, or it may be just to save space on the hard disk. So the first one is tar. Tar is like a zip file. It allows us to have one or more files into a single file. The size itself does not change, okay? This does not compress the file at all. What the tar does is it just combines it into a single file, so that way we can copy it around the network pretty easily. Now, if we want to compress the file, then we will put a gzip on it. So we'll take the tar directory, we'll combine everything into a single file, and then we'll compress it into a gzip file. This is what we will see within a normal Linux operating system to help provide extra space on the hard drive. So CZVF, one of those acronyms that's pretty hard to remember, but it is one of those that we should try to remember when we're trying to do tar and untarring of a file. So we want to create zip verbose file, extract zip verbose file. These are basically going from compressing to extracting, okay? So when we first want to compress a file and bring it into a tar file, what we'll do is we'll tar it, then we'll create it, we'll zip it, or verbose the file. If I don't type the Z command, then it won't compress. I will just tar it without compression. But if I want compression, I have to tell it that I'm going to compress it. So you'll notice that we like to put in tar.gz on our file names. This lets us know that it is a tarball. In other words, it's a compression of multiple files into a single file. And we also zipped it, we compressed it by using gzip. Now, we may want to say, what are we gzipping? Path to directory. And that's what we're going to put it into a backup file called backup.tar.gz. When we're ready, we can decompress the file. We can extract it by typing X for, instead of compress, we'll use X for extract. And we have to tell it is a zip file and it is a verbose file. In other words, it's a tar. Okay. So you'll notice VF on the end of all of our commands. So you'll see this 9 times out of 10 when you're dealing with everything in the real world, that the only big things that are going to change is, are you compressing a file or are you extracting a file? All right, so let's talk about processing of text files. We've talked about one of the philosophies being, well, small tools work together. And this is really where it's going to shine. We have a lot of tools that do a really good job by themselves, but how do we get them to work together? Well, by looking at all the files being text files, we should be able to take data from one file and bring it into another file. So how do we do that? There's a couple different things that you need to know about. There's three streams on all Linux operating systems that we need to know. There's called the standard in, which is the input. Usually this is our keyboard, but it doesn't have to be the keyboard. Our standard out is usually the screen. What is coming to the screen itself? We have standard out error, which tells us all the errors for a certain process. And then lastly, we can connect all of these together by using what we call the pipe symbol. Normally on the keyboard, it's above the enter key, and you normally have to hit shift and the pipe symbol. It's normally between the backspace and the enter key. And what this does is it will connect the standard output from one command to the standard input of the next by creating almost an assembly line. And this is really easy to get used to, especially if, like, say, I want to ls a directory but then grep it into another command. In other words, I want to find something. So here's a couple more tools for your toolkit. Text processing for it, like the first one is grep. This is where we're going to search for those patterns within a text file. This could be within a text file or within an output of another command. We have sed, which is the stream editor. Think of this as search and replace. Now, sed is one of those commands that is harder to get used to because it normally runs through expressions, but it is one of those very powerful commands to be able to find and replace things either within text or within the output stream of your search. Lastly, we have awk. Awk is a powerful tool to print specific columns. For instance, let's say I have first name, last name, address, and grade point average of all the students. Maybe I only want the grade point average within my script, and so since it's the fourth column, I can awk just the fourth column and pull that information out of my data set. A couple more commands is going to be cut. Cut is kind of like awk, it's just a little more simple. tr for translate. This will easily translate or delete individual characters. This is one of those things that I like to also call it truncate. You can use this to truncate different words or characters out of a string. And then lastly, we have word count. Word count is another one of those very useful tools, especially when making script writing, to figure out, well, how many lines am I dealing with? How many words am I dealing with within a certain file? We can do a word count -L for lines, and it will come back with how many lines are within a file. All right, so here's a pipeline example. So we have a whole bunch of tools that we've dealt with here. Now, the tools change depending on what we're trying to accomplish. We know the cat command from very at the beginning of how we read a file. So we can cat the password file within etc. And, well, we don't want to look at the entire file. Maybe we want to know all the users that are using the bash shell. We can then grep for bin bash. And we don't really want to know the actual users. Maybe we only want to know the number of users. So we've catted the entire file. We looked for all the users with bin bash, and then we counted how many lines there were. By doing the pipe command, we can take the standard output from one command and pipe it to the standard input of the next. And as we do this, it will get the final answer we're looking for. And all we cared about was how many users are using the bash shell. And this would give us our answer. Now, sometimes we want to manipulate the file output. Maybe we don't want to take it to just standard out. Maybe we don't want to pipe it into another command. But instead, maybe we want to send the output to another file. And so this is some way that we can create logs very easily within Linux. If I run a command and I do a single redirect, it will send it to a file, like a log file, but every time it runs, it overrides it. Now, if I want to append to that log file, instead of overwriting it every time, I would just use to. I would take the standard output of the command and output it to a log file. If I only wanted the errors, I could say to redirect, and this would be our standard error file. And maybe if I wanted both the errors and the standard out, I can use the ampersand. ampersand, redirect into a file. Now it all depends on what you're looking out to do here, but sometimes you want to create a log file for standard output and another file for the errors. And if so, you can do this. This is really one of those flexibility pieces of Linux and allows you to take the output of one command and put it into another file. Here's some examples. So if I wanted to look at a long listing of Etsy and put it into a file called etsycontents.txt, I would run the command and then redirect the output into a file. Now, if I wanted to append to a file, I would then append to it by using two redirects. So for instance, I could say date append activity log. And every time I run this, you'll notice in activity log, it will actually have the date over and over. It will just keep appending to it forever. Now, if I only want the errors, find anything with name of secret and put it into an error log. This is how I would do it. I would use the to redirect in errors.log. So this is really the straightforward way of redirecting any of the standard outputs into a log file by using different methodologies of redirects. Sometimes we want to put it to the screen and to a log file, and that's where T comes in. T acts like a splitter. Think of it like a T in a pipe, a T splitter, okay, where I can send the output at two places at the same time. What's really cool is I can say, give me the disk usage in human readable, pipe it into T, and the T will say, all right, I'm going to bring this to the screen and into disk usage.log. And if you want to know more about T, T is one of those cool commands. We can do a lot more with it. It's not just sending it to two places at once. We can split it as many times as we like. If we wanted to, we could take the output of T and send it to many files or even to another process. Because remember, everything in Linux is just a file. So even a file is a file, a process is a file, a device is a file. For instance, I could even tell this to send to a printer by just sending it to the printer file. All right, so we talked a little bit about editing files and how to manipulate the files themselves. We learned that Nano is one of the simpler ways of doing CLI text modifications. We learned that VI is the more advanced but more powerful way of doing it. We learned about locate, we learned about find, and that locate uses a database while find is a live search. We learned how to create links, hard and soft. We learned about tar and compression files, right, by using gzip. We learned how to chain some commands together. Now, we did learn a whole bunch of new commands here, and so as you're going through here, some of these commands are going to be one of those things that it will take muscle memory to understand which command does what. Between grep and cut and word count, I mean, all of these commands can work together, but you do need to know they exist. Now, piping is one of those cool features that not everyone understands at the beginning, but it allows you to take the standard input and the outputs and manipulate them in certain ways. We learned about redirection and how to take the output and where to go, and then we also learned about how to create redirection with a T, using T's to output to the screen and files simultaneously. All right, well, that was chapter 6. If you have any questions, please let me know. Otherwise, I will see you for chapter 7.